So this is Dr. K. Rajendra Prasad. I'm working as a professor and head for the departments of data science and cybersecurity. Today our topic is left recursion. What the understanding of left recursion and how can remove this left recursion is. The topic name is elimination of left recursion. So today our topic is elimination of left recursion. Previously we have discussed what is the difficulty of ambiguous and how can you convert in the ambiguous to unambiguous. That's very important. So another important thing is in the grammar point of view, some grammar predictions how the format is a left recursion. So first of all, today we have discussed how can you identify the left recursion from the given grammar. Means really whether the grammar having the some predictions in the form of left recursion or not. That is we have discussed today. After the identification of this left recursion and what the process basically you are going to apply for removing of this left recursion is. That is the idea is the elimination of the left recursion. That is the main topic of today classes. So first of all, you have discussed the what's the grammar basic idea, and again you have to revise the grammar ideas with help of the some variables, terminus and set of predictions and starting symbol. We try to define the some grammar, and after validating the grammar with any particular format, I think context-free grammar currently we are discussing. So as per the context-free grammar, the prediction is maybe in the form is the particular any non-terminal that can be derived as some combination of terminus and non-terminus. Then the corresponding grammar is called as the context-free grammar only. So because the intention is mainly there is no left and right context, whether right hand side and left hand side in the grammar predictions, then that is called as the context free. Hence the name is came from the context free grammar is no left context and no right context on the grammar. So for example, I am taking the context free grammar prediction is like this. A derives suppose A implies alpha. Here left context and right context both are to be null. Here also left and right context. Here also totally for the null. So this kind of idea we are getting the context free grammar is. So means in the context free grammar mainly the thing is left context and right context. In the case of context free grammar, okay, no left context. I am writing here for your understanding left context and no right context. No right context. So means I think totally it is called as this idea is called as context free. This idea is called as context free. So means the name is came from for the particular grammar is context free grammar, nothing but no left context and no right context. Hence the name is called as it is becomes context free. The corresponding grammar is called as a context free grammar. Okay, it is okay. And first you have to take in the main action is the grammar should be unambiguous. It is not in the form of ambiguous. Then only it is good for the compiler construction. We have concluded from the last class. And then after I think we have discussed one more properties. The grammar having the predictions, but you should verify whether the predictions have the form is left recursion or not. So you are trying to remove the left recursion for the any particular grammar, then it is good for the compiler construction. It's another important point. Means compiler construction point of view, when it is good nothing but the grammar should be unambiguous. And the second point is no left recursion. No left recursion. That's why we are going to discuss. Suppose left recursion problem is occurred really in the grammar, and how can you remove that left recursion? The problem is. So that is we are discussing today. A grammar is said to be left recursion. I think when nothing but the grammar prediction how the form is A implies A capital A alpha. So this is the syntax for understanding of left recursion. Means every prediction we can say that it is a left recursion. Okay, the prediction that should be in the form of A implies A alpha form. So what is the A is? A is a non-terminal. It is a non-terminal, and right hand side that should be matched. Okay, means what the I think left hand side you have taken non-terminal. The right hand side also you should start with the same symbol only. These symbols are both are same. So this symbol is appear where nothing but right hand side, left side. Okay, then it is called as a left recursion. So because of every time you want to make a substitution, again you have to getting the problem is A implies A alpha. Okay, so it means again you have to go for the expansion. So we are going to expand the formula of A implies A alpha. Recursively, you can call capital A values many number of times. Okay, that problem is called as left recursion. Now you have to verify. I'm going to take like this. I want to make a substitution. What the A value is again A alpha. Again, I have to make the A substitution is again it becomes A alpha. So we have to getting many alphas. Okay. So every time you have to recursively call itself the same production, maybe you are getting this kind of alphas many things. So the problem is basically the same. What the derived string? Okay, at the left hand side and right hand side of the first terminal that should first symbol that should be same. So that case the entire production is having the form of left recursion. So any grammar production that consists of the production form is A implies A alpha form, then that kind of idea is called as left recursion. The production is in the form of left recursive. So a grammar is said to be left recursive if it has a non-terminal such that there is a derivation A implies A alpha for some string alpha. What is the alpha? Is the combination of strings and non-terminals. This is called as alpha. Cap A here strictly you should allow only for single non-terminal. Cap A is a single non-terminal. So in the case of A implies A alpha, A is a single non-terminal and alpha is nothing but some combination of terminals and the non-terminal. So that is a basic idea for identification of left recursive in the grammar productions. Okay. So what the problem is, I think come to the grammar point of view, coming topics we have discussing the many number of parsing techniques like top-down parsing technique and bottom-up parsing technique. Here one of the variant of parsers is top-down parsing technique. Suppose the grammar have the some left recursive productions, then we cannot handle using the top-down parsers. Thus, there is a difficulty of I think left recursive productions. Means any left recursive productions that happens in the grammar, then we cannot recommend the top-down parsers. So top-down parsers cannot handle left recursive grammar. That is one of the biggest problem with the left recursion. So after that, I think how can we eliminate some kind of transformation technique we are going to apply for removing of left recursion. So this kind of a particular transformation needed to eliminate the left recursion. Then you can make use of those resulting operations without having the left recursion. We can easily apply the top-down process after eliminating the left recursion for the existing grammars. So that is I think we are discussed today. So what the left recursion problem is? Main left recursion nothing but any production that can be in the form of capital A implies capital A alpha, that is a left recursion. So we show that I think top-down process cannot handle those kind of left recursive grammar. So hence it is required to remove the left recursion in the existing productions of the grammar. Then after that only we can make use of the top-down process for the left recursive free grammars. So here this is a basic syntax. You try to understanding what the left recursion is. Suppose the production is having the A plus A alpha slash beta. Then this is called as form is left recursive because of here this variable and this variable. Okay, means in the derivation left hand side variable is capital A and the right hand side the first symbol is capital A. Both are same. So I have the production form is like this only. Then you have to facing the problem is left recursive with what the variable is a capital A variable. Okay. So once you have to identify left recursion is happen. Okay, as per this syntax after comparing your grammar production with this syntax, definitely you make sure that the left recursion is happened. Then immediately you have to take the decision. Okay, how can you eliminate the left recursion? The elimination of left recursion directly cannot eliminate any particular symbol. Just you have to make some replacement with a new terminal. Only. That is the basic idea of elimination of left recursion. The elimination, but the symbol cannot be removed directly, but the symbol you can treat as some replacement of new terminal. Okay, that is the basic idea of I think elimination of left recursion. So you have to seriously observe that and what are the changes here. Okay, instead of taking this production, you are taking the two alternative productions. Here becomes the beta and the A dash. So what the beta is? I think rather than this format, some other things. No, these are the betas. So you have to make merge with you start with the terminal should be start with not A, not a A. Now the terminal should be start with the beta. Beta is another alternative of the given grammar productions. Okay, so it means where you satisfy the left recursion, where in which case you are not satisfying the left recursion. Not satisfying the left recursion cases, you are getting the beta's values. That beta you should start it here. After that, you take one new variable that is called as A dash. That is called as A dash. This is, I think, the first idea. And after that, what the A dash is. So what the A dash nothing but it becomes. So here you are trying to seriously attempting only for beta and alpha values only. You cannot attempt the capital A. If you attempt the capital A, again you have to get back the you are facing the same problem. That is the left recursion. That's why here what is the A dash nothing but. So here A dash nothing but you are taking after A some part is there, alpha is there, no, you are identifying. You make a substitution of alpha and also A dash. Okay. So how can you stop this? I think the process of substitution is okay. Definitely you end with some null symbol. Okay, when you go for end with null symbol, the substitution process that may be terminated at least somewhere. Okay, after expected. After reaching your expected string, okay, the process totally terminated with the substitution of the null symbol only. So this is the idea of left recursion, and what is the general form of left recursion is, again I am saying is A should start with A alpha slash beta. This is the left recursion form, because here you should the first variable that should be on right hand side, that should be matched with the left hand side variable, then it's called as the left recursion. So I think how can you eliminate? Okay, you cannot eliminate that directly, but indirectly you can apply. You are going to apply the process. So, okay, after that, automatically the capital A that will be ignored by taking the some other new variable C A dash. Okay, that is happened here. Instead of taking this production, you are taking some other new productions here. A implies beta A dash and A dash implies alpha A dash slash null. So means these two resulting productions what indicates nothing but non-left recursive productions. So this idea of elimination of left recursion. So here you have to try to see what happens with the help of some real-time example. Okay, here I am giving some examples for the left recursion, and how can you identify some different alphas values and betas values. So here, for your purpose, I am taking many values of betas, because of I think in the grammar sometimes you are getting a single beta only, beta 1 only. Some of the cases you are getting the many betas, beta 1, beta 2 like that. Okay, like we are taking the alphas also same. Sometimes we are getting only for single alpha only. Sometimes we are, I think we do based on the different examples. So we are getting the many times alphas also. So I am extending the same idea of left recursion. What is the left recursion is? Okay, I am extending the formula of left recursion. Any production that can be obtained in the form of A implies A alpha 1, A alpha 2, so on, A alpha A. So wherever you are getting the alphas values and prior to the alpha, the common variable is capital A. That should be matched with the left hand side variable. This is a form of left recursion. And I think sometimes may not start with the capital A, those are called as beta values only. Beta 1, beta 2 and so on, beta n. So means any person have in this form, A implies A alpha 1, A alpha 2 and so on, like beta 1, beta and so on. This is called as left recursion. This corresponding idea is for identification of left recursion, we make use of this kind of syntax. Okay, here what is happens here, left recursion, like left recursion is happen. So this is a left recursion. By using this here, I am taking here the specific example. So for these examples, you can find how many alphas are there, like how many betas are there. Okay, I am taking the first production here. So here I am taking this totally for the alpha 1, this alpha 1, this totally called as the beta 1. Is it right? So here this first production kind of is, so I think this is a common. This both are common. This is also same. So definitely you say that it's a left recursion is happen. Left recursion is happen. Okay. So E implies E plus T slash T. So plus T is totally called as the alpha 1. You are saying this is the beta 1. So what is the A? This is the A. Is in the form of, what the form is, A implies A alpha 1 slash beta 1. Okay, alpha 1 is value is plus t, and capital E value is E value, beta 1 is t. So you know the A, capital A, alpha 1 and beta. So then as per the, I think after removing of this left recursive, okay, what happens? Before that, you try to recall what the syntax is following is A implies beta A dash and A dash implies alpha A dash slash null. You can apply this the syntax. Okay, so first I am taking what the syntax is. A implies beta A dash, beta A dash, and again A dash implies. So what the next another form is alpha A dash slash alpha A dash slash null. We should remember these two. I think replacement of new productions for removal of left recursion. So what the results you are getting? A becomes here A nothing but what A is here capital E. First production point of A is capital E. This becomes beta is talking for T A dash, nothing but E dash. And what the E dash is here, E dash becomes alpha. Alpha is nothing but you are taking the plus T. No? Alpha is the plus T. Plus T, and again E dash slash null. So you have to getting these two new results in the place of first prediction. In the place of first prediction. So like that you should convert left recursive prediction into non-left recursive predictions. Non-left recursive predictions. So as per the idea of the syntax is, if the prediction is the form of A implies A alpha 1 slash beta 1, then what are the new predictions after removing of this left recursion is A implies beta A dash implies alpha A dash slash null. So this I think the common idea is you are following for removal of left recursion, that is elimination of left recursion. Similarly, I will try for another example here. Okay, here, I think this prediction there is no left recursion, okay, but you have checked the second example. You also have a left recursion. We are taking here T implies T into F slash F. So here this is the common one. It is you call as this is capital A. The star F is called as this is the alpha. This is alpha. This is called as beta. So I think this is also I think some problem of left recursion because of left hand side the variable capital T is matched with the right hand side of first non-terminal. This is capital T. So I am trying to defining the new productions that may have the non-left recursive productions, the resulting productions. So first you take T implies what the beta is here. F is the beta. F is the beta. Then T dash. Okay. So what the T dash is? T dash becomes. So as per the I think values you are taking the alpha only. Okay. Initially alpha is what the alpha value is star F and T dash and one more value is null value. So I think these productions are these new productions. Okay, you are taking in the place of the production is T implies T into F slash F. So with that, so you know the idea of how can you convert the left recursion productions into non-left recursion productions. Means in the given grammar you should identify all productions. In any case you are facing the problem is the left recursion. Kindly you try to remove the left recursion by taking the appropriate this syntax. Okay. So after getting the all productions that becomes a non-left recursive, we can make use of all these productions in the easiest manner for what application is a top-down parsing application. So here the big advantage of this topic, elimination of left recursion topic, where it is useful nothing but top-down parser case, this topic is very useful. So once again we have to revise the ideas like this. So here the elimination of left recursion, with the help of the complete algorithm, okay, algorithm point of view, okay. So you should know the process, what the input we are taking, grammar G with cycles or null productions or no cycles or no null productions. You should take initially, I think no null productions or no cycles only, and you try to convert the equivalent grammar with left recursion grammar. So as per our syntaxes only, just you should follow. Okay. So these are our syntaxes. So how can you identify the left recursion is here you make sure that okay the format after replacement of the things that becomes totally for non-recursive left productions. Okay, means left recursion without that idea, because of no left recursion productions. That is our objective. That is the output you have to getting after applying this algorithm. So finally, you have to take many examples also. Here also you are facing the same symbol problem. Means here, how many different alpha? Previously you have to sing only for single alpha only, but here many alphas. This alpha 1, this alpha 2. So what are beta values? Beta 1 and also beta 2. So finally, after applying left recursion, okay, removal of elimination of left recursion, what are the resulting productions, sir? First, you are trying to the productions are betas only, beta t space null. So after that, again you are trying for alpha a dash, alpha nothing but c, small c, a dash. One more alpha is ad and a dash. So another one is finally you start with the symbol is called as a dash with the null value, a dash with the null value. So this, I think this resulting, it can show the idea is elimination of a left recursion, Initially the grammar portion have the recursive format, left recursive format. So after applying this elimination of left recursion, okay, what are the resulting predictions? These are the resulting predictions. So what is the advantage? I think, but these kind of predictions are useful for what kind of parsing is top-down parsing. So top-down parsing, expecting all predictions, okay, that becomes only for non-left recursive format only. Suppose the predictions are in the left recursive format, we try to convert those predictions into non-left recursive format. So after converting all predictions that becomes into non-left recursive format, you can make use of this resulting grammar, okay, for what exactly is a non-left recursive predictions grammar for the purpose of top-down parsing. Because of the reason is top-down parsing cannot handle left recursive grammar predictions. Top-down parsing can handle what kind of predictions are non-left recursive grammar predictions. So that purpose, it is required to convert left recursive grammar to non-left recursive grammar. So that is the advantage of left recursion. Okay. Similarly, we try for some of the examples. Okay, as per your understanding ideas. So this case also, if any, I think idea of left recursion is occurred. Okay, try to convert the left recursive grammar. That becomes how it is converted into non-left recursive predictions. Already I discussed this. So all these topics, I think, regard to the idea of left recursion and regard to the steps of elimination of left recursion and what is the purpose of left recursion. I referred mainly from this textbook, Compilers Principles, Techniques and Tools. Okay. So with this, today we are concluding the topic of elimination of left recursion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.